this video, we're going to look at how one can derive the equation of a straight line using just the gradient of the line and a point that lies on the line. So let's investigate how to do this. So first of all, recall that a straight line has gradient m equal to y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are any 2 points that lie on the line. Recall also that a line has equation y equals mx plus c, where m is the gradient and c is the y-intercept. So, bearing these two pieces of information in mind, let's say that we have a line with gradient m. So I'll just sketch a random line on my axes and label its gradient as m. And let's say also that the line passes through some point x1, y1. So it doesn't matter where it is. Let's say it's here on the line. It's just some known point on the line. And then let's let xy be any point on the line. So x and y are variables and they take the value of any point on the line. Then with this setup, it must be true that m, the gradient, is equal to y minus y1 over x minus x1. So y and x are variables, but they can only take values of points that lie on the line. Therefore, it must be true that if we do y minus y1 and divide by x minus x1, since y and x are some point on the line, x and y I should say, and x1, y1 is also some point on the line, we must get the gradient. But this is now an equation that we can rearrange to get the equation of the line in a more standard form. So if we start by taking the x minus x1 over to the other side, we get that y minus y1 equals m times x minus x1. Now we can multiply out the brackets on the right hand side and we can take the minus y1 over to the right hand side. So we end up with y equals mx minus mx1 plus y1. So if you're unsure what I've done here, there are several videos in the algebra playlist of videos that discuss how to expand brackets and how to rearrange equations. So you should go and watch these before finishing this video. Okay, so we've now rearranged the equation and we have a straight line equation. Looks a bit strange, but let's have a look. So here's the gradient, m, in front of the x as we would expect. And then added on at the end is some big constant, which is the y-intercept. Remember, this is a constant because m, x1 and y1 are all constants. So minus mx1 plus y1 is some constant. If we knew what the values of these numbers, we could calculate it and we just get some single number. So this looks a little complicated, but let's just try an example. So before we do the example, we're just going to state this result at the top here for reference. So the equation of a line can be found using m equals y minus y1 over x minus x1, where m is the gradient and x1, y1 is a point on the line. So if we're given the gradient and a point on the line, we can form this equation and then we just have to rearrange it to get the equation of the line in a more standard form. So let's try this example. Find the equation of the straight line that has gradient m equals minus 4 over 5 and passes through the point 5 minus 2, and sketch the line. So we'll find the equation and then we'll finish by sketching it. Let's see. The equation is given by, well, we just use the formula at the top of this box, but we know what m and x1, y1 are, so it's given by minus 4 over 5, that's m, equals y plus 2, because remember it's y minus y1, but y1 in this case is minus 2, so it's y minus minus 2, which is y plus 2, and then x1 is 5, so on the bottom we have x minus 5. So it's now just a case of rearranging this equation. So we'll start by taking the x minus 5 over to the other side. We get the y plus 2 by itself, and this equals minus 4 over 5 times x minus 5. We'll then multiply out the brackets on the right hand side. So we have y plus 2 equals minus 4 over 5x plus 4. We have a plus 4 here because the minus 4 over 5 multiplied by the minus 5. The 5's cancel and the minuses cancel, so we're just left with plus 4. Finally, we'll take the plus 2 over to the right hand side to get the y by itself. And we have y equals minus 4 over 5x plus 2. Because of course when we take the plus 2 over to the other side, it becomes a minus 2. And 4 minus 2 is 2. So we found the equation. Now we just quickly sketch it using the same method we did in the previous video for sketching lines. So we know the y-intercept is 2 because we can just look at the equation. It has a plus 2 on the end. So let's mark that point on the y-axis. We'll mark a point at 2 on the y-axis. So the line is going to go through this point. We also know the gradient is minus 4 over 5. Now this means that when we increase x by 1, y decreases by 4 over 5. Now that's the same as saying that when we increase x by 5, y will decrease by 5 lots of 4 over 5, and then the 5's will cancel. 5 lots of 4 over 5 is 5 times 4 over 5, the 5's cancel and we just get 4. So if we increase x by 5, y decreases by 4. We know it's going to be a decrease because there's a minus sign in the gradient. So we go 5 along the x-axis and 4 down the y-axis, and we get to this point here. So this is our line.
And she saw that swirl of yellow